All right. Good morning, guys. Good afternoon, whatever time of day it is for you. I'm Miss Tarpon, and today's lesson is on weather. So specifically, we're going to be looking at these three standards that are listed on the board. Basically, just looking at what are the factors that affect weather and how do we differentiate between weather and climate. So these first several slides are going to be just some examples. And we're going to kind of go quickly through some of these slides. But there are several different factors, but a few main ones that influence weather. Number one, we've got mountains on here as an example. So think about what would be different in the mountains versus sea level. So take me, for example, I live close to the coast in Somerville, South Carolina. Maybe some of you guys live more in the upstate, like closer to Greenville. So there's going to be a couple different things that are going to affect the weather in those two different places. But one of them being mountains, especially if you're like really up into the upper state. We've got some of the Appalachian Mountains there. The biggest thing there is going to be elevation. So as we climb up a mountain, if you've ever hiked up a mountain, if you've ever gone on an airplane up into the sky, you've noticed probably one thing. What do you think that is? Well, you may have noticed more than one thing, but specifically about the weather, that's going to be that it gets cooler as you go up higher. So elevation is going to be one of our big factors that affects the weather. One other thing that this slide is discussing here is basically what's called the rain shadow effect. So as we go up in a mountain, sometimes those mountains are high enough to where the clouds actually can't come past the mountain. The mountain actually acts as kind of like a barrier. So on one side of the mountain, you might get a lot of rain, as is in this example right here, the Sierra Nevada range. Some of that Pacific Ocean weather coming on and kind of colliding with the mountains. A lot of rain on that western side of the mountain range, but then on the other side of the mountains, the eastern side, it's going to be very dry because of that rain. It's called a rain shadow, which we don't have that term listed here, but it's the same principle. All right, so mountains are a big thing that influences weather. And then here's the rain shadow that I was just discussing. So we got lots of rain, almost like a rainforest on one side of the mountains and then a rain shadow on the other. This happens in South America too. Another factor that's going to influence weather is going to be bodies of water. So I mentioned like I'm in Somerville. Some of you guys might be more in the upstate. I'm not super close to the coast. But think of like if I was in Charleston, or even I have lived down in the Florida Keys too, which are islands, and any island really too, are surrounded by water. Water is going to basically take longer to change in temperature than air. So especially on an island being surrounded by water, you're going to be influenced by the temperature of that water quite a bit. So for example, when I lived in the Keys, our highs and lows weren't too drastically different, maybe 10 degrees, mainly because that water that surrounded the island didn't change temperature as quickly as the air at night. So we were more influenced by the water temperature. That's called specific heat, that property of water that takes it longer to change temperature. It holds on to that temperature more. Okay, so other things that influence weather, ocean currents. So we know the ocean currents, based on the other video I did, if you've watched that yet, they help distribute heat basically from the equator to the poles. Just think of it that way. Just distribution of heat, because it gets hotter around the equator, much colder at the poles of the earth. And so what we see is ocean currents helping distribute that heat. For example, the Gulf Stream is warm and it moves that warm, moist air into the North Atlantic. So basically from the tip of Florida, and it goes up along the coast. And even further up than what this picture is showing. It goes up to much colder areas and helps distribute some of that heat. Another thing here that's more of a human influence are cities, believe it or not. So cities are going to be absorbing a lot of that solar radiation just because they're darker colored. That's a big part of it. It's called the albedo effect. And there's a term for that. It's called urban heat island. Urban heat island. So they can be as much as 10 degrees higher than the surrounding area. Because if you think about like a kind of like a gray, dark pavement, and then in comparison to like, you know, more natural colors, that gray, dark is going to absorb more heat also just because of the material too. Sometimes city buildings can amplify winds as well. So for example, Chicago being called the Windy City, those buildings can disrupt the natural flow of wind and cause this kind of like upward effect where the wind actually rushes more through those buildings than it would normally. Right, and then just there's a nice little graphic for you to compare weather conditions. We're going to take a look at some of these others as well that we haven't talked about quite yet. Go ahead and answer those questions on your own. Okay, so comparing weather, do various areas of the country have predictable weather patterns? And we're going to take a look at that. And to make those generalizations, we have to ask specific questions and examine the climate data. So remember, climate is the more long-term pattern of temperature and precipitation, while weather is the more short-term state of the atmosphere. We're going to talk more about that. Okay, so climate. One of the kind of graphs, I guess, that go along with climate is called the climograph. Very exciting. We've got on a climograph the x-axis being time or date, as in months, and this one, so J for January, February, March, and so on. And then the y-axis being two y-axes, one being rainfall on this left side, and then one being temperature on the right side. So the climographs will be for a specific place. This one is in New York. And so we can see over basically the range of a year, how much rainfall. So those are the bars. So let's take, what month are we in right now? October, for example. Get a little less than 4 inches of rainfall in October in West Point, New York. The orange line is referencing the temperature, which is on this right side y-axis. And so in October, average temperature right around 55 degrees, I would say. So that's how you read these graphs. But these are important in climate, looking at the overall climate of an area. Remember, long-term for climate. Another really important factor when it comes to climate is latitude. So remember, latitudes on Earth, 0 degrees being the equator. We are in the northern hemisphere. So as we go up in latitude, they start being degrees north. And so if you take New York, for example, it's right around 40 degrees north. Miami is, of course, lower down at 25 degrees north, being closer to the equator. Latitude has a major effect on climate because it's the further you are from the equator, basically takes you further away, a little bit further away from the sun. And we know the equator is where it gets that most direct sunlight to you, most direct rays of sunlight. So lower latitudes tend to have higher average temperatures than those higher latitudes. And you can see that on the graph here. Again, we've got dates on the x-axis, temperature on the y-axis. And New York, being the blue line, is lower overall than Miami, being the orange line. So latitude, big influence on climate. And then you go ahead and answer that one on your own. And how does wind affect climate? So that's one thing we haven't talked a lot about yet. We talked about that city effect of like Chicago being the example. But we do have some prevailing winds on the earth. I believe you've had that already in one of your Nearpods. So for example, we have the jet stream in this graph or this map that you have on the screen. And New York is experiencing prevailing winds over its land. That means just kind of like a constant wind. Eureka is receiving prevailing winds too, but from the Pacific Ocean. So Eureka is way over in Oregon, or no, it's California. And experiencing those winds from the Pacific Ocean. Remember we said, well, we talked about the ocean kind of takes longer to change temperature basically than air. So it's going to be greatly influenced by the temperature of the water. Eureka is in comparison to New York, which is getting these winds from the land. And then you've got your graph here at the top. So New York is the blue line temperature, and then Eureka is the more red line. And do you see how constant Eureka's temperatures are? And that's due to that effect of the ocean being there and being just a more constant, stable temperature basically than the air. Okay, so go ahead and answer that one. And how high above sea level is this location too? So we've talked briefly at the beginning about elevation. So in this example here, we have Mount Washington and Portland. They're within 1 degree latitude of each other. Mount Washington, though, look, is in the mountains here. This would be like I guess it would be the upper Appalachian Mountains. And then Portland, Maine, not Oregon, being just here on the coast of the Atlantic. But Mount Washington being a much higher elevation is going to be influenced by that elevation. As you go up in elevation, air pressure actually decreases, which causes those molecules to kind of move slower, leading to that lower temperature. So here's Mount Washington, the green line on your graph. You can see that just the average temperature is much lower in comparison to Portland, the red line. So elevation. And how is precipitation affected by elevation too? So decreased temperature can cause moisture to condense and precipitation to increase in the mountains, for example. So Mount Washington getting on average more rainfall than the Portland area. Okay, landforms too. We talked a lot about mountains. We talked about that rain shadow effect. And air masses as well. So Seattle and Miami receive maritime air masses. That just means air masses from the kind of coming off of the ocean. Maritime, marine, those words mean ocean. So observe the latitude difference and observe the type of maritime air masses each city receives. So we've got Miami getting that tropical warm air mass from the Atlantic Ocean. Remember that Gulf Stream is influencing temperature there too. And then Seattle, in the far opposite corner of the United States, getting that much cooler maritime air mass over Seattle. A lot of times you get fog in those areas like San Francisco, Seattle, known to be pretty foggy due to the difference in temperature between the ocean and the air. And a lot of it is that maritime air mass. And so then you can look at the graph here. Temperature for Seattle on average much lower than that of Miami, also influenced by latitude, but also influenced by those air masses. You've got, a collaboration board to fill out here. Okay, so we said we're going to differentiate between the two terms, weather and climate. Remember we said weather is more of like a short-term picture of what is the atmosphere like on a given day. So things like today, our high is It's really nice out today. I think it's like 65. Our low is 42 and very little chance of rain. So that's the weather in comparison to the climate of an area. We're looking at the more long-term conditions. So I could say climate of Summerville, South Carolina, in general, are mild temperatures. I could give a range, like average between, 50 to 75 degrees Fahrenheit over the whole course of a year. And on average, we receive, I don't really know how much, but we'll just say 3 inches of rain per month. So some examples here. Climate, we said that. Often describe using words such as humid, hot, temperature, dry, desert, or cold. Temp and precipitation determine the climate of a region. Those are the two main things. Okay, so what influences climate? We said elevation, big one. Latitude, probably the biggest one, how far away from the equator. So just like we're in the northern hemisphere, the further you get up north, the higher the latitude number, the lower the temperatures, usually, generally speaking. You can also go south from the equator, of course. And so those are going to have a south after the latitude number, like 10 degrees south. You're south of the equator. But the same principle applies. As you get further south from the equator, the colder it gets. So eventually Antarctica being the coldest. Also, the seasons are opposite. I don't think we're talking about that in this one, though. So we said elevation, latitude affect the temperature. Also, large bodies of water affecting the temperature too. That specific heat effect. Also tending to be a lot more humid near large bodies of water. So just more, basically that means just more water molecules in the air, not ones that we can see, but just microscopic, like water vapor. So areas like the Great Lakes, more water in the air leads to more snowfall too. They get those, I think they call it like the lake effect, those big giant snowflakes. I've never been up there, but I want to go. And then same thing with the Gulf Stream, like we talked about, a warm ocean current that goes near the land will warm the air temperatures as well. And then opposite, a cold ocean current that goes near the land will cool the air over the land. So we talked about the Gulf Stream warming the air on the east coast of the U.S. and taking some of that solar radiation north. We didn't talk about the Pacific Ocean as much, but there is the California current that goes in the opposite direction, so pulling cooler water down the coast of California, Mexico, eventually, and it actually influences the air to be a little bit cooler in California. I think that's why the temperatures are nice there. It doesn't get so hot, and that's a lot of it due to that current. So again, temperature and precipitation, big things that determine the region's climate. There are climate zones or regions on Earth characterized by similar climates. We've already learned about them, or we're going to look at them, but as we've already learned, elevation, latitude, ocean currents, proximity to oceans or large lakes, mountains, prevailing winds, all influence temperature and precipitation. So these are kind of like your more minor-ish factors that influence the big ones, temperature and precipitation, that all determine a region's climate. And your video. Okay, so climate zones. These are the 5 major climate zones. You might have heard of them described as biomes before too. But basically tropical wet, dry, temperate marine, temperate continental, and polar. So a little bit different maybe from biomes, but very similar. We're going to take a look at each of them. Some examples of tropical. So areas of lower elevation around the equator. So if you look, equator's in the middle, remember like we said, kind of middle of Earth, 0 degrees in latitude. And then temperatures of at least 64.4 degrees Fahrenheit These are the tropical wet conditions. Hot and humid, at least 6 centimeters of rain per month in rainforests. So that would be tropical wet would be the darker blue areas in this map. And then there's also tropical wet and dry. So that means alternating extreme periods depending on the season. A lot of times there's going to be like a really rainy monsoon season in these areas. And then also on the other extreme, dry seasons. And so that's going to be like the middle blue. If you can see it, it's kind of hard to see on the map. But a lot of the savannas, like in Africa, I know some of these Asian countries experience monsoon seasons like the Philippines, and even like some of the Central American regions too. Like Costa Rica has a wet season, I know. So that's tropical. Okay, and then dry climates are going to be things like deserts. So arid means dry. Deserts, less than 25 centimeters of rain per year, or precipitation per year. Semi-arid are usually located on the edges of those arid regions. So still dry, but a little bit more rainfall. For example, these are the types of ecosystems, steppes, prairies, and grasslands that are classified as semi-arid. And go ahead and answer that one. All right, then we've got temperate marine. So 3 types of temperate marine climates. Marine west coast, so think California. Mediterranean, in terms of the Mediterranean Ocean, so Europe, and then Northern Africa. And then humid subtropical. So think like Miami, Fort Lauderdale, those types of areas, South Florida. Temps 50 or above in warmer months, and then 26 to 65 in colder months. Pacific Northwest is located in temperate marine climate zone, temperate marine. That's like Seattle, that area, lots of fog, definitely gets cold there. Mediterranean climates have 2 seasons, a cool rainy winter and a warm dry summer. So think like Greece, Italy, those regions. Haven't been there before, but I want to go. And then humid subtropical have summers that are super hot and winters with lots of rainfall. So the good old southeastern United States, for example. And then here's just a nice map showing the climate zones of the continental United States. And so here we are, a big green region, South Carolina, classified as humid subtropical climate. Very, very tip of Florida, the red color, tropical wet and dry seasonal climate. And then if you look at California, is mostly orange. It's actually got that as a Mediterranean climate. But and then the whole northwestern corner of the U.S. being marine west coast climate. And then, of course, continental is within the middle. And we don't have to go into too much depth with that. All right, and then temperature. So some of these humid continental regions are caught between tropical and polar air masses. Subarctic climates are located north of the humid continental climates. So, for example, Russia, Alaska, Canada. So if you look here, these are these highlighted regions. These bright blue regions caught between tropical and polar air masses. So subarctic climates are north of the humid continental climates. And finally, polar regions are just like the name suggests, polar. So like the northern parts of the latitude are considered ice cap regions covered with ice and snow. Temperatures always at or below freezing. Greenland and Antarctica, which isn't highlighted green down here, but definitely would be polar. Typically short, cool summers, long, bitter, cold winters. Permafrost is a term that you may not have heard before, but that just means permanently frozen soil year-round. Even in the summer, you dig down to a certain point and that soil just stays frozen. Yes, very cold. And I believe you have, yep. So you've got your last little collaboration board here. Go ahead and fill that in. And then the time to climb, which you can do as well. So thank you. Hopefully you are feeling a little bit more confident about the difference between those two terms, weather and climate. Remember, weather, short term, climate, long term. So weather, maybe looking at a day's temperature, highs and lows, precipitation. Climate, looking at the more average, like we live in a humid, hot area in South Carolina, I would say most of the year, more than half. Thanks for being here, and get your Nearpod done. Make sure that's all finished up. Have a great rest of your day.